We are looking at notes 2.4, which is on solving polynomial equations. And I just presented this one question to you that's going to really encompass everything that we need to do when we're trying to solve polynomial equations. The good news about this topic is that if you're good with factoring, solving polynomial equations is super easy because it just involves one extra step. So this video might kind of be like a review for you right now, except for the final step, okay? So let's read through what it says. The paths of two orcas playing in the ocean were recorded by some oceanographers. The first orca's path could be modeled by the equation h of t is equal to all of this stuff right here. And the second is modeled by h of t equals all of this stuff right here. Okay, so we've got our two functions right there, where h is the height above or below the water's surface in centimeters, and t is the time during the first 8 seconds of play. So we only care about the 8 seconds at the beginning, that's all. Over this 8-second period, at what times were the two orcas at the same height or depth? So essentially, I just want my two h's to be the same, okay? So if my first function is h of t equals 2t to the power of 4 minus 17t cubed plus 27t squared minus 252t plus 232, and I want that to be the same as this piece right here, I can just set it equal to each other. So I can say equals 20t cubed minus 200t squared plus 300t minus 200, okay? But because I have a nonlinear equation right here, this is a pretty complicated looking equation, I'm going to try to get everything to one side and set it equal to 0. Once I set it equal to 0, it's going to be so much easier for me to solve, because once I factor it, I can set each factor equal to 0. Just like we do with quadratic functions and quadratic equations, except now we've got a quartic. We've got it to the power of 4, okay? So let's go ahead and do this. This 2t to the power of 4 has nothing like it, so I'm going to just keep it 2t to the power of 4. Now I'm going to get rid of this 20t cubed by subtracting it from this negative 17t cubed. So when I subtract it, I end up getting negative 37t cubed, right? Because I'm going to subtract 20t cubed here and subtract 20t cubed here, okay? I'm going to add this 200t squared on this side to cancel it out, but whatever I do to one side, I do to the other side. So this ends up being 227t squared, okay? And then I'm going to subtract this 300t from both sides. These t's cancel. Right here, this becomes negative 552t. And then I can add 200 over here and add 200 over here, so I've got plus 432 equals 0, okay? Okay, so now I'm going to look at some possible factors that will work, some possible a values for x minus a, right? So there are a lot of values because I'm going to be looking at this 432 right here. There are so many factors of 432, and then I can also take all those values and divide it by 2 as well. So I'm not going to list out all possible values. I am just going to list out a few and see what happens. And then if I need to list out more values afterwards, if I exhaust all my possibilities I've listed out, then I'll go ahead and look at more possibilities, okay? So I know that a could be plus or minus 1. Is 432 divisible by 2? Absolutely, so it could be plus or minus 2. It is divisible by 3, so it could be plus or minus 3. It's divisible by 4, so it could be plus or minus 4. It's divisible by 5. Sorry, it's not divisible by 5 because it ends in a 2, so it can't be plus or minus 5. It is divisible by 6. It's not divisible by 7. It is divisible by 8. And it is divisible by 9. So let's stick with the single digits for now, and if we need to go into double digits, we can. Okay, so the next thing I'm going to do is I'm going to let f of t equal my expression that I have here, this one right here. So 2t to the power of 4 minus 37t cubed minus 227t squared minus 500 plus 227t squared minus 552t plus 432. And I'm going to find f of 1. So here, f of 1 would be 2 times 1, which is 2, minus 37 times 1, which is 37, plus 227 times 1, which is 227, minus 552 plus 432. Okay, I'd go through and I'd evaluate that and see if my remainder is going to be equal to 0 or not. Evaluate this, I end up getting 72. By the way, I'm going to make myself a little note that I'm using the factor theorem to figure this out. Okay, that's what my process is right here. So I get 72. I know that it doesn't have a remainder of 0, so a equals 1 will not work, so x minus 1 isn't a factor. Okay, so let's go ahead and try f of 2. So just to save time, I know you guys can evaluate these values right here, and you can also use the graphing technology to evaluate this answer. We get f of 2 is equal to negative 28. So 2 won't work. So let's go ahead and try 3. So let's find f of 3. When I plug 3 in for t, every time I see a t right here, I end up getting negative 18. And if you want to verify on your own, please feel free to do so you can make sure you truly understand what's going on. Okay. So this doesn't work. This does not give me the remainder that I want. Remember, I want a remainder of 0. So let's go ahead and evaluate f of 4. So if I do f of 4, I end up getting 0. So this means that there's no remainder, which tells me that x minus 4 is a factor. Okay, so now I can go ahead and take this f of t right here that we have right here. I'm going to take this whole thing right here and I'm going to rewrite it with my factored expression. But before I can do that, I need to divide out this x minus 4. So I'm going to use synthetic division. I'm going to put a 4 on the outside, and then I'm going to write down all of my coefficients. So my coefficients are 2, negative 37, 227, negative 552, and 432. Okay, I'm going to bring the 2 down. So I get 2 times 4, which is 8. Add negative 37 and 8 together, I get negative 29. Multiply negative 29 by 4, and I end up getting negative 116. Add these numbers together, I get 111. Multiply 111 by 4, I get 444. Add these two values together, I get negative 108. Multiply negative 108 by 4, and I get negative 432. Add these two guys together, I get a remainder of 0. So that means that I can say that this f of t piece that I have right here, I can rewrite it a little bit differently. I can say that this f of t, I can say that this f of t is equal to x minus 4 times, and then this stuff right here is telling me that, well, let's see, let's work backwards. This is the remainder, this is the 0 power, 1 power, second power, this right here is my third power, this 2. So this is 2x cubed minus 29x squared plus 111x minus 108, okay? I'm getting closer to where I want to be. However, I need to continue to factor this. So I'm going to continue to try some values using the factor theorem in my f of t expression, my original f of t expression right here. So we tried 1. We tried positive 1. So the positive 1 is done. The positive 2 is done. The positive 3 is done, the positive 4 was done, and it worked. So let's try positive 6 now. So let's go ahead and see what we get when we do f of 6. So when I do f of 6 and I plug it into my calculator, I want you to do that right now just to make sure you're totally okay with this. Plug it into your calculator, see what you get, and then come back to me to see if your answer is correct or not. Okay, so when I do f of 6, I should get negative 108. Which means that this does not work. I'm not going to worry about 6 anymore. So then the next value that we have on our list is, the next value that we have on our list is positive 8. So let's try positive 8. So f of 8 is going to give me, when I plug it all in, I get negative 208. So let's do the next one on my list, which is f of 9. And when I do f of 9 and I plug all that information in into my original function that I have right here, my original f of t, I get a remainder of 0, which means that x minus 9 is a factor. Okay, but when I do this right here, when I actually divide it all out and I do my synthetic division, this time I'm not going to use these coefficients. I'm going to use where I left off. I'm going to use this piece because I've already divided out this x minus 4. So I can just divide this 2x cubed minus 29x squared plus 111x minus 108 by the x minus 9. So right here I'm going to put 2, negative 29. Again, I'm using just these coefficients, 111, and negative 108. Okay, so let's go ahead and see what we get when we do this. I'll bring the 2 down. 2 times 9 is 18. Add these two guys together, I get negative 11. Negative 11 times 9 is negative 99. Add these guys together, I get 12. 12 times 9 is 188. Negative 108 plus 108, add those together, they cancel each other out, you get 0. So now that I confirmed that I have a remainder of 0 and I've been able to divide it, I can now say that this new function, f of t, is equal to keep, and I apologize, before I said I used x's and I should not have. Sorry about that. This should say t to t cubed, right? 29t squared plus 111t minus 108. Sorry about that. So when I do this here, this expression, I still have the t minus 4. Now I have t minus 9, okay? And then what's left over right here, this is my remainder. This is my 0 power, my 1 power, my second power. So this is going to be 2t squared minus 11t plus 12. Okay, now that I've gotten to this point right here, I can continue to factor this expression. So when I factor this right here, I'm going to look for 2 factors that multiply together to give me 2t squared. Well, 2 is prime, so that makes it easy. I just have a 2t here and a t here. And then I also know that these last 2 terms have to multiply together to give me 12. So let's try some factors of 12. Let's try 3 and 4. I'll put a 4 here and a 3 here and see what I end up getting. So this right here gives me 4t. This here gives me 6t. It does not give me the negative 11t that I want. So I'm just going to switch these. But a quick tip really quickly before we move on. If there's no GCF here, then there is going to be no GCF here. So since these have something in common, it doesn't make sense for me to put the 4 there because that would mean that they would have a GCF of 2. Okay, so I'm going to take out the 4 here. I'm going to put the 3 here instead, and I'll put the 4 here instead and see if that works out a little bit better for me. This gives me 3t. This gives me 8t. That gives me, if I use both negatives, it gives me the negative 11t that I want. So it works out nicely for me. All right, so now I've got this t minus 9, this t minus 4, but if you remember when we were solving this problem initially, we ended up getting, right here, let's see where we left off. Up here, it was equal, it was equal to 0, if you remember that. So we just let f of t equal all this stuff right here, but instead of f of t, now we're just going to say it's equal to 0. Okay, so let's go ahead and solve this problem. So this ends up being, first thing I'm going to do is I'm going to put this t minus 4 and this t minus 4 together, and I'm going to say it's t minus 4 squared times t minus 9 times 2t minus 3. Okay, so I can go ahead and set each factor equal to 0. So I'm allowed to say t minus 4 equals 0, t minus 9 equals 0, and 2t minus 3 equals 0. So that means that t equals 4 here, t equals 9 here, and then when I solve here, I'm going to add 3 to both sides, so I get 2t equals 3, which means t equals 3 halves. So let's go back and see what the question is saying. If you notice, however, the only extra added piece for solving polynomial equations is what we did right here. Once we factor it, we can just set each factor equal to 0. Okay, so let's go back up here. and see what the question is saying. It says, at what times were the two orcas at the same height or depth? So when are the t-values going to be the same? But remember, it has to be within the first 8 seconds of play. So let's go ahead and see what our answers are. We've got 4 seconds. This works. 9 seconds is too far out of our range, so this is inadmissible. Okay, and then 3/2 is 1.5 seconds, so this one is good. We're good to go for this one. So therefore, we can say the orca's paths intersect at 1.5, and let's see what the unit is. I believe it was in seconds, so it's 1.5 seconds and 4 seconds, and that's our answer. Okay, so don't forget that when you have a bunch of factors multiplied together to equal 0, you can set each factor equal to 0. That's why we make it equal to 0 here, so we can go ahead and solve our equation if we have an equation that needs to be solved. Okay?